There are many cases in which the charge passing through a material is not constant. It does change with the time. So for this particular problem here, the charge that it passes through a material is given by this function here. So the charge is a function of time, and the charge, the unit is in coulomb. So this is how the charge passes through a material, which is a function of time. If that is the case, we need to find out what is the average current between the time t equals to 0 and time t equals to 2 seconds. And what are the instantaneous current at two particular times, time equals to 0 and time equals to 2 seconds. Let's find it out. If you must have taken the university physics class, and if you know the position as a function of time, that you can find out the average speed and the average velocity. The same thing here is. Here the charge is a function of time, and now you need to find out the average current and the instantaneous current. So in order to find out the average current, what we need the charge at two particular times. In this case, the time equals to 0 and time equals to 2 seconds. We need to have the values at these two times. So let's find it out. This is at time t equals to 0 second. What we're going to do is just simply going to plug time equals to 0 in this equation. So if we do that, then time t equals to 0 q 5 0 squared, and this is a constant. If we do the math, we'll get 2 coulomb. And now let's plug in time equals to 2 in this equation. So it will be 2q minus 5 2 squared plus 2. And again, if you do the math, then the number you'll get is negative 10 coulomb. So the average is defined. What is the final charge minus the initial charge, that we call the delta q. So q at the time equals to 2 seconds minus q at the time equals to 2 seconds. In between these two time, so this is the charges that has passed through. At a time equals to 2 seconds, the value is minus 2, and time equals to 0 second, the value is 2 coulomb. If we do the math, we'll get the negative 6 ampere current. Okay. So this is the current that has passed through between time equals to 0 and time equals to 2 seconds. Now let's find out the instantaneous current. As I mentioned, the instantaneous current is defined as the current at one particular time. And the way we defined it is the rate of change of current with respect to time. So the first derivative of charge is called the instantaneous current. So let's take the first derivative. The q, this is the q value. So this is the equation, and the q is given. So we just plug in here q, and if you know this function dx to the n over dx, then the derivative will be nx to the n minus 1. The same formula I'm going to apply here. It will be 3t squared minus 5 times 2, 10t. This is a constant. If we take a time derivative, this will be 0. So this is simply equal to 3t squared minus 10t. Now plug in time equals to 0. So here I'm just plugging time equals to 0 here. So in this equation, if I plug time equals to 0, then this is 3 0 squared minus 10 times 0. So it is 0 ampere. And now going to plug time equals to 2 seconds here. So this 3 2 squared minus 10 times 2. If we solve it, we'll get minus 8 ampere. So this is the current at time equals to 0 second was 2, and then at time equals 2 second it was minus 8, and the average current in between those is minus 6 ampere current. Okay, so this is how we find out the average current and the instantaneous current in a circuit. And at the end, I would say do not forget to like, share, and subscribe the channel. Thank you very much.